All right, so the first thing we're looking for our first equation is we're looking for the period here. So the period, remember that comes from doing 360 degrees, because in this case theta is in degrees, 360 divided by whatever number is multiplied by x or theta. In this case that's a 2. So I'm going to do 360 divided by 2 here to find my period. So if I do 360 divided by 2, that gives me 180 degrees. There's my period for the first one. Because remember what this means. Period is how wide is one cycle. 2 means it completes 2 between 0 and 360. So of course if it's going to complete 2 between 0 and 360, each of them must be 180 wide. All right, next up, amplitude. Amplitude comes from whatever number is multiplied out front of sine or cosine. In this case, there's no number written there, so it's assumed to be 1. And then finally, the midline. The midline comes from whatever number is added or subtracted on to the end. So in this case, that's a -5. But now, one little tweak to that. -5 is just a number, and yet midline is supposed to actually be a line.
So it's y.
And so we're actually going to write our midline then as y equals -5. All right, so that's how you would approach the first one. All the others are basically done the same way, so go ahead and progress through and do the remaining 3 on this page. When we now take a look at the one in the bottom left-hand corner, this theta minus 180, what's that do to our period? That's usually the question that comes up at this point. Well, in order to find period, we always do 360 divided by whatever number is multiplied by x or theta. But notice there's no number multiplied out front here, so it's like it's a 1. Our period here is actually still going to be 360 degrees. It's unchanged. If you wanted to, you could actually do 360 divided by 1 to get the same number. So what's the minus 180 do to the period? Nothing. Not a single thing. The minus 180 is the phase shift, and that's all it is. It does not affect the period, it does not affect the amplitude, and it does not affect the midline in any way, shape, or form. All right, and then other little details as we look at all the answers here. One other area where sometimes people get tripped up is actually on this one on the top right for the amplitude. Because amplitude, remember, is the distance from the midline to the top or the bottom of the graph. That means it's the stretch part. So the 4 stretches it to be 4 times taller. The negative, it's flipping it. The negative is doing the reflection. That does not affect how tall it is. And so the negative is not to be included as part of the amplitude. Only the stretch is. So amplitude, always positive. Next up, we're going to do these 4. Now, the difference between the last set and this set here is that in this set we have x, which is measured in radians. So each of these values, you got to use radians instead of degrees. Otherwise, same idea. Please find the period, the amplitude, and the midline. Before you go too much further, though, having actually tried, I hope, the first one, let's actually take a look and see how that first one would be done to see what the radians do to us differently. So we need to find the period first. Now, just like with the previous set in degrees, I'm going to divide by whatever number is multiplied by the x. So I'm going to be dividing by 3. But since it's in radians, what am I dividing by 3 this time? 2 pi. Absolutely. So in this case, in order to find the period, I do 2 pi divided by 3, which is just going to be 2 pi over 3. We can leave it as a fraction. It's actually better to leave it as a fraction and leave it in terms of pi here. And so the only difference when switching between degrees and radians on these types of problems is that with degrees, you do 360 divided by that number. And in radians, you do 2 pi divided by that number. That's the only difference between them. It does not affect the amplitude, and it does not affect the midline. And so both of those, we find them just the way we did before. The amplitude is the number multiplied by sine, which here is 8. And since there's no number added or subtracted onto the end here, my midline is at 0. All right, so now here's the rest of the answers. So let's take a look and see some little details along the way. All of these are in radians, so for the period, we're always doing 2 pi divided by the number. Now, you notice in the bottom left and the top right, there is no number multiplied in front of the x. And so it's just going to stay the 2 pi for that reason. If you wanted to calculate it out 2 pi divided by 1, you certainly can, but of course that's still going to leave us with 2 pi. So just like in the last one, we saw how like that 180 did not change the period, the amplitude, or the midline. The same thing happens here when I add pi, for instance, because it's adding or subtracting it. It's a phase shift only.
Wait, so...
And the last thing to note here is in the last one, in order to find our period for that one, we did 2 pi divided by 4. Well, that starts as a fraction of 2 pi over 4, but then we do need to reduce it. So that's why the final answer there is just pi over 2. Now, each of these that we've taken a look at so far today have been what would be considered probably the simple scenario. There is a little bit more to some of these equations, though. In your notes from last week, we actually wrote down some equations where it had both the phase shift and a period change included in it. And so we want to see how to work with them when they do look that complicated. So that's what these are. The processes are still all the same, but again, I'd like you to please find the period, amplitude, and midline for these three. Notice in this case, we're back to degrees. Just, I want you getting used to and comfortable with having that extra set of parentheses in there.
Wait, this was all...
All right, so seeing how we actually do this then, for finding the period is still determined by the frequency. In other words, it's determined by the number multiplied by x or theta. In this first example, that's the 5. So I'm going to end up doing 360 divided by 5 here. That gives me a period of 72 degrees. And then the amplitude, it's still the number that's multiplied out front. So in this case, it's 1 because there was nothing put in there. And midline is still the number that's added on the end. There was nothing added on the end, so that's why it's 0. But notice what this tells us. The extra set of parentheses is in here, but we still deal with the numbers the same way as before. The 90 still did not change anything. But sometimes when we introduce the extra set of parentheses, people figure, oh, well, it must be changing that too. And actually, we have to deal with it with that extra set of parentheses in there. The phase shift is actually the 90. If we distributed the 5 in, like some people end up saying, well, don't I need to distribute that in? Nope. The phase shift is just the 90. If you actually distribute it in, it's going to throw it off. Go ahead and do the other two. All right, now here's each of the answers that we get from there. Check each of them. Now, the big one here is this last one, because that one, of course, includes absolutely everything we could possibly do to one of these equations. And if you can find the period, amplitude, and midline from that, then you're probably going to be able to handle anything that might come up along the way. All right, last set here. We got to see the complicated looking ones, this time in radians. So, please again find the period, the amplitude, and the midline for each of those. All right, and then just check it on the first one again, and then I'm going to give you time to work on the others. To find the period, I'm going to be dividing by 10. What am I going to divide by 10 in this problem?
Pi. 360.
2 pi. We got to divide 2 pi by the 10. And if I do 2 pi over 10, that becomes pi over 5 when I reduce it. From here, the one that I expect to cause any other lingering problems is actually probably the 1/3. Because in order to deal with that, I'm still going to be doing 2 pi divided by that number to find my period. But that means doing 2 pi divided by 1/3, and sometimes we get a little rusty with dividing fractions. So if you are a little rusty on how to divide by a fraction, the rule is that we multiply by the reciprocal. In other words, flip the second fraction and change the division and multiplication. And so in order to do 2 pi divided by 1/3, really then I'm doing 2 pi times 3. And so that's why our period here ends up being 6 pi. And then you can check each of the rest of the answers, make sure they're looking pretty good.